now moving on to polygons. We've got to talk about the relationship of polygons inside of a circle. So here's a polygon. More specifically, if it has 5 sides, what kind of polygon is it? It's a pentagon. It has 5 sides. The polygon that is on the inside of the circle is inscribed. Write that down. Draw this picture in your notes and write that down. You need to know what inscribed means. This is an inscribed polygon. More specifically, it's an inscribed pentagon. Why? Because it has 5 sides. The circle that goes around it is circumscribed. Spell it out. Write it in your notes. The way that I remember that circumscribed means on the outside is circumference. Circumference is the measure of the circle's perimeter. Right? We don't say perimeter when we deal with circle, we say circumference. So circumscribed means the circle is on the outside of the polygon. All of these vertices have to be on the circle. So you got inscribed, the polygon is inscribed, meaning it's inside the circle. And you got circumscribed, meaning the circle is on the outside of the circle. Okay, it's just terminology that you need to know in order to understand these two theorems. All right, Alan, read this theorem 6.11 out nice and loud for me.
If a right triangle is inscribed in a circle, the hypotenuse is the diameter of the circle. Conversely, if one side of an inscribed triangle is the diameter of the circle, the triangle is a right triangle, and the angle opposite the diameter is the right triangle.
All right, here's your drawing. Eyes up here. If I take a triangle, now instead of a polygon, I'm saying a triangle. More specifically, I'm saying a right triangle. If I take a right triangle and I inscribe it inside of a circle, meaning this is on the circle, this vertex, this is on the circle, and this is on the circle. If I take those 3 points and they're on the circle and I say that it is a right triangle, then by definition, I know that the hypotenuse is the diameter, meaning it goes through the center of the circle. Well, why is that important? What difference does that make? Well, that tells us a lot. It tells us that there's a semicircle from here to here, and that the measurement of that is 180 degrees. Okay, that's going to help us a lot when we're trying to do some of these problems in just a second. It also tells us something about these angles. What is true about X and Y? No, they're not necessarily the same. They equal 90. What is the geometry word for that? Starts with a C. Right? Complementary means that they add up to 90 degrees. The way we remember that is what comes first in the alphabet? C. C instead of S. Supplementary means they add up to what? 180. So we also know that angle X and angle Y are complementary. What's true about this arc here in relation to the letters I've got so far? What is its measurement?
Twice Y.
2y, very good. What is true about this arc here? What is its measurement? 2x. What is true about 2x, 2y, and 180? What do all 3 of those have to add up to? 360. So there's a number of ways to get problems out of this theorem. What you have to understand is, if this is a diameter, then this automatically is a right triangle. If it's a right triangle, then this automatically, the hypotenuse has to be a diameter. Okay, that's what the theorem is saying. I doubled it. It's an inscribed angle. Here's an angle. It's making an arc. It's inscribed. I have to double it to get that measurement. Let's say this was 30 and this was 60. If that's 30, then that's 60. If this is 60, that would be 120. I have to double it. It's inscribed. All right, anybody else? Last one. Read it for me, Huff. Nice and loud. Yep.
A quadrilateral can be inscribed in a circle if and only if it's opposite angles.
All right, so now we've changed gears again. Instead of talking about a triangle, now we're talking about a what? Quadrilateral. How many sides does a quadrilateral have? 4. Eyes up here. I need everybody's eyes up here. Quadrilateral has 4 sides. It says it is if and only if what is true. What has to be true about the quadrilateral?
Opposite angles.
Opposite angles. So if this one is 60, what does this one have to be? No, not 60. That would be congruent. We just got done saying opposite angles are supplementary. Supplementary means they add up to what? 180. So if that one's 60, what would this one be? 120. They add up to 180 degrees. If this one is 75, then what does this one have to be?
150,
Can you do it in your head? 105. 105. So 60 and 120, 75 and 105. Opposite angles have to be supplementary. All right, here. Let's play a little bit. See how many of you are paying attention. If this angle here is 75, then what is the measurement of this arc from here all the way around over to here?
150.
Not 180. It would be double this, which is how much?
150.
150. What is this arc from here to here?
240.
If that was X, nope, not 240. If that was X, can you figure it out? No, you need some more information. How much is it from here all the way around over to here? How much? From here all the way around over here is 210. I need letters, but you get the idea. That would be 210. Can we figure out X?
103.
You need some more information. 210 and 150, that adds to 360. I'd have to give you one of the sides in order for you to know, I think. Yeah, I'd have to give you one of the sides, but you get the idea. Nowhere does it say this is a semicircle, right? I don't have a diameter, okay? I don't want you to get confused by that. All right, any questions? Here's an example problem. 80 and 100 and 70 and 110. Yes or no? Can that quadrilateral be inscribed inside of a circle? Yes or no?
Yes.
Are opposite angles supplementary?
Yes. Yes.
Yes, they are. Then the answer is yes. It can be inscribed inside of a circle. All right, how about this one?
No.
How about that one?
No.
Can that quadrilateral be inscribed inside of a circle? The answer is no. Why not? Because opposite are not supplementary. And so the answer would be no. That's a typical problem. Okay? So let's recap. We talked about inscribed angles. Half as big. Inscribed angle, you got a circle. That's okay. I've got an inscribed angle. It's half as big as the arc. I talked about the one where you get two inscribed angles. You got the same arc from here to here, and you have two different angles. X and Y have to be congruent. We talked about polygon. Polygon is inscribed if it's inside. The circle is circumscribed. And then we talked about theorem 611 that talked about a right triangle. If it's a right triangle, then the hypotenuse is the diameter. Then we talked about quadrilaterals, and the opposite angles have to be supplementary. There's like 9 things here on page 205. Okay, questions? That's good.